So I would also like to reiterate that in the group, I have already posted that from this Sunday onward, we are going to have a test, right? So this all 720 marks test is there. So every week we are putting a test. So all of you are supposed to go through the test. Okay. So this test will give you an idea that how to sit at least for 3 hours, because this is a practice, because many times what happens that students are not having practice of sitting for a long duration, right? So please take out 3 hours time and just appear in the test every Sunday.
So each subject will be on the different portal, right?
Different portal means?
Like we have different ID for bio and a different ID for physics. So each will be on this respective IDs, right?
No, actually, the ID which I gave you, can you tell me the name of the ID you have?
For bio, it is Tirtha 1, and for physics, it's Tirtha.
Okay, so for bio, you please use this, because from the same ID, you will be having all the three subjects.
Okay, sir.
Once you are done, let me know. This Ansika is Ansika Mishra or Ansika Singh Pune? Ansika, are you there? Not replied. Shall I move? So I hope everybody has taken note of it. So let's move ahead. You see, there are two types of synapse. Okay. One what we call electrical synapse, second what we call chemical synapse, right? So have a look at this diagram. So this is the electrical synapse, right? In case of electrical synapse, what happens? That the pre and post synaptic neurons are very close to each other. Okay, they don't have any neurotransmitters. So the current can directly flow from one neuron across the another through these synapse, right? This is what we call electrical synapse. So it's very obvious that impulse transmission across electrical synapses are faster than in comparison to the other one where we see that it is going to happen through the neurotransmitters. But what happens that electrical synapses are very, very few in number, right? So mostly the synapse is going to occur through the neurotransmitters, means that is the chemical synapse. And if you ask you that where the electrical synapse is found, that these synapses are mostly found in the CNS. Okay. But as far as the PNS is concerned, the synapses are primarily the chemical. So once again, you can see this diagram. So this is, there is a no gap, but here you see the gap is present in case of the typical chemical synapse. Okay. Please write down. Once done, let me know. लिख लिया क्या? Shall I move? Okay, fine. So now we will talk about the chemical synapse, right? So what happened over here? First of all, axon potential is generated, right? Then it goes to synaptic vesicles, you can see there. And from then it goes to presynaptic membrane. Then there is a neurotransmitters, and this neurotransmitters goes to synaptic cleft. And finally, what happened? That postsynaptic membrane is actually being excited, right? So this is the flow chart. Please note it. Click here. Okay. All right. So let's discuss in detail that what is going to happen during the chemical transmission, right? We know very well. What happens, you see, when nerve impulse reaches the presynaptic knob. So this is the presynaptic knob, and through action potential, the nerve is actually reaches, right? So what happens? It is going to depolarize the presynaptic membrane. And once it's depolarized, what will happen? It causes the opening of voltage gated calcium channel. That is important. So once it reaches this particular membrane is going to be depolarized, and once it is depolarized, it opens voltage gated calcium channel. So calcium will enter. So there is a diffusion of calcium ion in the presynaptic nerve, right? So you see the calcium has entered. Right now you can see that this is the calcium that is entering, right? Now once the calcium enter, what happens? That they causes movement of synaptic vesicle to the surface of the nerve. What happened? Calcium binds to the synaptic vesicles, right? And after binding, they facilitate the very binding of the synaptic vesicles to the membrane. Okay, so there is a one specific protein called docking protein. By that docking protein, actually, it binds. Okay, now synaptic vesicles, what happens? They fuses with the presynaptic membrane, and once they fuses, they get ruptured. And as a result of rupturing, you can see there that here what happens, that the uh, neurotransmitters is actually being released. So what we have seen the very first step, that the generation of uh, the action potential causing the depolarization. Number two, the calcium gate opens. Number three, the calcium facilitate the bindings of to the vesicles. And finally, four, it facilitate the very opening of the neurotransmitters. I hope ये सबको समझा होगा. Is it clear? Understood? So please draw the diagram as well. लिख लिया क्या? Done. Shall I move? Okay.
Yes, sir.
Sure. So what we see next, synaptic vesicles then return to the cytoplasm or presynaptic knob for refilling. देखो जैसे यहाँ पे release हुआ, so again it will go for the refilling, right? So this cycle will continue inside the synaptic bulb. Now the released neurotransmitters, what will happen? They will bind to the postsynaptic membrane. So this is the postsynaptic membrane you can see there. Okay. So once they bind, they will depolarize this particular structure. And as a result of depolarization, what happens? Axon potentials will go beyond that. Okay. So write on this.
Done, sir.
Okay. So what happens? You see, some of the neurotransmitters is going to bind, right? So other unbound neurotransmitters, they will immediately get lost from the synaptic cleft. Okay. Now this is going to cause the depolarization. The depolarization of the postsynaptic membrane opens the sodium channel and thereby causing influx of sodium ion, जो कि already हम लोग पढ़ चुके हैं. The sodium ion बाहर आता है, then the things, the impulses start moving. So this cause depolarization and generate action potential. In this way, actually what happened, impulse get transmitted to the next neuron along the synapse. Okay.
Done, sir.
Okay. चलो एक चीज डिस्कस करते हैं, दैट इज वेरी इंपॉर्टेंट, ग्रेडेड पोटेंशियल क्या होता है। तो इसके पहले हम लोगों ने एक्शन पोटेंशियल पढ़ा था। नाउ ग्रेडेड पोटेंशियल व्हाट एग्जैक्टली इज। नाउ यू सी दिस ग्रेडेड पोटेंशियल्स आर जनरेटेड बाय ligand gated ions. Okay, now what is ligand gated ions? Let's try to understand. So ligand gated ions are those that is going to be activated by the binding of some ions. For instance, you see that the potassium, the calcium was a ligand gated ions, because once the calcium binds, then the gates open. Okay, so the very difference between graded potential ion and the normal action potential ion is that potential can vary in amplitude. But you see, in case of action potential, in case of nerve, what we have discussed, that the value of the potential always remain the same. Okay, now here what we see, the amplitude is proportional to the size of the input stimuli. Okay, now second, the graded potential can be either depolarizing or hyperpolarizing. In both the cases, the graded potential can generate, right? Now another important thing is that graded potential can be transmitted over short distance, right? And a strength of the signal decays as we move with the distance from the generation. Okay, another two graded potentials can be added, right? And the transmission of graded potential can occur uniformly over direction. Okay, so you see, acetylcholine receptors are the one of the most studied ligand gated channels, because you see in the post receptors things, right? So this is, suppose this is a receptor, and here the acetylcholine is actually binding, right? So after binding, what happens? The action potential is actually generated. So once this ligand is actually bound to some receptors, and when the depolarization or other event of transmission from nerve is generated, this is what we call graded potential. And once again, I would like to reiterate that the graded potential is quite different from the action potential what we have studied earlier. Okay.
Done, sir.
Okay. So I hope the difference between the normal potential and action potential is absolutely clear at your end, right? Anna?
Yes, sir.
So this is about the neurotransmitters. So neurotransmitters are the small molecules that are liberated by presynaptic neuron, right? We know very well. So this change can be, so what happens, they cause change in postsynaptic membrane. So this can be either direct depolarization or hypopolarization or activation of the second messenger. So this is how the neurotransmitter acts, right? Right on this. Clear?
Yes, sir. Done.
चलो, ये सारे न्यूरोट्रांसमीटर्स हैं. तो कौन सा न्यूरोट्रांसमीटर्स कहाँ होता है, दैट इज इंपॉर्टेंट. एसिटिलकोलिन जो है, दैट इज फाउंड इन बोथ CNS एंड PNS. कैटकोलामिन्स, दैट इज सिंथेसाइज्ड बाय टायरोसिन. नॉरएड्रेनालिन, जिसको हम लोग नॉरएपिनेफ्रिन भी कहते हैं, that is used as certain synapse in CNS and PNS. And dopamine, you know very well, used as a certain synapse in CNS, right? So these are most of the important that is frequently used. Okay.
Done, sir.
चलो फिर आज इतना ही पढ़ना था हमें, right? So if you have any questions, please go ahead. Any questions you want to ask?
No, sir.
Chalo, that's all. Thank you.
Thank you, sir.
Thank you, sir. Good night.
Good night.